one of today's most prominent and advanced physicists has expressed his opinion on the matter. Michio Kaku, recognized for his outstanding contributions to the fields of physics, has recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists thought could not exist. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. The discovery is both exciting and revolutionary, challenging existing theories about the formation and development of galaxies. It is therefore worth keeping an eye on these developments. The confirmation by such a distinguished scientist as Michio Kaku underscores the importance of these findings. Michio Kaku is an outstanding figure in the scientific field, a physicist of American and Japanese heritage. He is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the amazing results of the James Webb Space Telescope mission. His willingness to embrace new discoveries and share them with the public highlights his commitment to advancing our understanding of the universe. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied. The enthusiasm and almost amused tone of the renowned stellar physicist are evident in his comments on the discovery made by the James Webb Space Telescope, expressing that this has been a highlight that has piqued his interest. Join us to discover the implications of Michio Kaku's discovery of these 6 massive galaxies. Michio Kaku is a scientist who has always been willing to consider new theories. Throughout his life, he has demonstrated an openness to ideas that challenge the status quo, understanding that Einstein's equations of relativity and Newton's laws, while foundational, are insufficient to capture the full complexity of the universe. Kaku understands that the discoveries of the new telescope have the potential to enrich the scientific field. Although many of his colleagues have not been able to adopt this view, it is generating concern and insomnia among the Big Bang proponents and opponents of quantum mechanics. However, this only provokes laughter from Kaku. The jwst has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only 200 million to 700 million years after the Big Bang. The team of astronomers who made the discovery have dubbed these exceptional galaxies universe breakers, because, if confirmed, they would revolutionize our entire understanding of the universe. The implications of these findings are profound, suggesting that the universe's early years were far more dynamic and complex than previously thought. Something doesn't fit here anymore. The Big Bang theory tells us that the cosmos was a hot mess after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for the objects to reach sufficient density and produce light. The formation of complex structures, such as galaxies, was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense luminosity indicates that they were probably forming hundreds of new stars each year, whereas our galaxy forms stars only sporadically. It remains uncertain exactly when the first galaxy formed. Researchers have not been able to determine this so far. The only thing that is clear is that initially, there may have only been single stars or groups of stars, which eventually joined together to form larger and larger accretions until dwarf galaxies developed. The small galaxies encountered other galaxies and gradually grew. According to previous theories, highly organized and massive galaxies could not have existed at that time, which raises the question of whether the universe is much older than previously believed or whether complex galactic arrangements developed much earlier. This circumstance is difficult to accept for conservative science, which still finds problems with this model, and some branches of physics heavily refuse to accept this discovery and question possible errors in the age calculations. Michio Kaku is aware of this and had this to say: "There are many examples of old and false theories that stubbornly persist because of the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their falsity. Therefore, the fundamental work in any science, especially in physics, rests within the experimentalists who keep the theorists honest. In fact, on Earth, we know very little about the true beginnings of the cosmos." This quote from Kaku emphasizes the importance of continuous experimentation and validation in the scientific process. The Big Bang theory was established in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in time and space was beyond people's imagination. And even today, scientists still face difficulties in understanding it. However, it is important to consider these probabilities once again. These new demonstrations do not fit at all with what researchers have based for decades on the Big Bang theory. However, science has shown time and time again that reevaluation and openness to new ideas are an integral part of the scientific process, as is the confirmation of certain theories and observations. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe and that these particular structures occupied a defined space. However, we now know that everything in the cosmos is in motion. Planets orbit stars, stars move within their galaxies at hundreds of kilometers per second, and entire galaxies move rapidly through the cosmos, the fate of which we cannot yet even predict. This dynamic understanding of the universe challenges long-held beliefs and underscores the need for ongoing inquiry and adaptation in scientific thought. Today, scientists are challenged to accept uncomfortable truths and to understand that theories are not absolute truths until they are rigorously tested or confirmed by accurate observation. The idea of the Big Bang arose from the realization that galaxies are moving away from each other, and this distance is proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures seemed to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the Sun revolved around us also had physical evidence for their assumptions until coincidences or technological improvements came along that provided a clearer and more accurate picture. Right now, we are witnessing a similar situation. Scientists expected the new James Webb Space Telescope to confirm the assumptions related to the Big Bang, but instead, they have come across these 6 galaxies that seemed impossible. This reminds us that science is constantly evolving and that scientists must be open to new discoveries and rethink existing theories based on the available evidence. The unexpected finding challenges the current understanding and prompts a reassessment of long-standing cosmological theories. Researchers use redshift as a tool to determine certain quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light sources and the observer move relative to each other. To understand this, you can imagine standing still and seeing a car coming towards you. As the car moves towards you, you hear the sound of the engine getting louder. However, once the car passes you or moves away from you, the sound of the engine changes. This is because the sound of the engine varies as the car moves. The same is true of light. When a light source, such as a distant star, moves towards us, the light we perceive shifts towards bluer hues. On the other hand, when the light source moves away from us, the light shifts towards redder hues. This phenomenon is called redshift. Physicists have converted redshift values into velocities and distances for measurement in the study of the cosmos. However, it is important to note that small errors in these measurements could have significant effects. The measurement techniques previously used are currently under review, and it is interesting to see what results scientists will arrive at. As for the latest demonstrations related to our cosmos, it is necessary to consider whether they are really based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires rigorous analysis and careful review of the data and methodologies used in the research. The current scrutiny and reevaluation of measurement techniques highlight the evolving nature of scientific inquiry. Thank you very much for watching the video. As always, we remind you that you can post your doubts in the comments box. If you like the video, do not forget to hit the like button, share it so it reaches more people, and subscribe to the channel so you don't miss more content like this. Thank you so much for watching, and see you in the next one. This call to action encourages viewers to engage with the content, fostering a community of curious minds eager to explore and understand the latest scientific discoveries. The study of our universe, with its vast expanses and intricate celestial bodies, continues to captivate and challenge scientists across the globe. From the early theories of the cosmos to the latest discoveries, made possible by cutting-edge technology. Each revelation reshapes our understanding of the cosmos and pushes the boundaries of human knowledge. One of the most profound and enduring questions in cosmology revolves around the origin and evolution of galaxies. Galaxies are cosmic cities of stars, gas, dust, and dark matter bound together by gravity. Understanding how galaxies form and evolve is crucial not only for unraveling the mysteries of our universe but also for confirming or challenging existing theories such as the Big Bang theory. The Big Bang theory, proposed nearly a century ago, posits that the universe originated from a singular, infinitely dense point and has been expanding ever since. This concept emerged from observations of the universe's expansion and the cosmic microwave background radiation, considered the afterglow of the Big Bang. However, the recent discovery of 6 massive galaxies by the James Webb Space Telescope has sent shockwaves through the scientific community, potentially upending the foundations of this theory. These galaxies, formed in the universe's infancy, should not exist according to current models. Their existence raises crucial questions about the validity of the Big Bang theory and the timeline of galaxy formation. What makes these galaxies so intriguing is not just their size but their age. They formed between 200 million and 700 million years after the Big Bang when the universe was still very young. Yet, despite their youth, these galaxies are more massive than the Milky Way, which is 13.6 billion years old. The discovery of these galaxies suggests that the processes leading to galaxy formation might have occurred much earlier and faster than previously thought. It also raises the possibility that the early universe was more complex and varied than our current models can explain. The existence of such massive galaxies so soon after the Big Bang challenges the notion that galaxies gradually evolved from small, irregular structures to the massive, organized systems we see today. If these universe breakers are confirmed, they could force a significant rewrite of the history of our universe. This situation is reminiscent of the paradigm shifts in science when new evidence forces the abandonment of long-held beliefs. Just as the heliocentric model replaced the geocentric view of the universe, these new findings could lead to a reevaluation of the Big Bang theory and our understanding of the early universe. Scientists are now faced with the daunting task of reconciling these discoveries with existing theories or developing new models that can better explain the observations. This may involve revisiting the assumptions underlying the Big Bang theory or exploring alternative explanations for the formation and evolution of galaxies. In conclusion, the James Webb Space Telescope's discovery of 6 massive galaxies challenges our understanding of the universe's origins and the timeline of galaxy formation. It highlights the importance of remaining open to new ideas and evidence in the scientific process. As we continue to explore the cosmos, we must be prepared to adapt our theories and embrace the unknown, just as Michio Kaku has done in his reaction to this groundbreaking discovery.